Hello, future engineer. So, in this video, we are going to solve this type of question which is asked in your examination from DSAP subject. So, how to solve this type of question? This is usually asked for 7 or 8 marks in your examination. So, let's see. We'll solve step by step. So, this question is also very important because this is asked in 2023 spring from Pokhara University. So, let's solve it. So here we have given x80 given 5 cos 650 plus 7 cos 850, isn't it? And we have given bit rate is equal to 1000 bit per second, and this is 1024. This is called as number of quantized level, which is called L. So let's get into brief. So here we have asked what is the sampling frequency and folding frequency. So sampling frequency simply means here we have a formula. So okay, we have just written given data here. X80 is here. We have x80 is given 5 cos 650 plus 7 cos 850. So bit rate, as I told you earlier, this is 1000, which is a bit rate. Okay, let me erase this. So I think everything is clear. So 1000 is a bit rate here, isn't it? 1000 is a bit rate. So number of quantize is L, which is called as L. This is 1024. So you can see number of quantized level, this is 1024, and number bit rate is here. We have 1000 bit per second. So we have to find out the bit sample. So we are preparing for a sampling frequency. So we need to find out sampling frequency. For that, we need to find out number of bits. So to find number of bits, we have this formula: B is equal to log base square L. So log base, there are two types of log in your calculator. So one is log, another is log base. So you have to be use log base log so in your formula, and you have to write 2 in your base. So after that you can write a value of 1024 bit rate. So after that you can get the number of bits. So number of bit is here. We get 1000 number of bit, and now we are going to find out the sampling frequency. So we have asked sampling frequency and folding frequency. So we'll find out sampling frequency. For the sampling frequency, we have a formula. Sampling frequency is equal to bit rate upon number of bits slash sample, isn't it? So we have a number of bits is equal to 10, and bit rate is equal to, we have given 1000 bit is given in the question. So you can just check it out. So after that we can just get the 100 hertz. This is 100 hertz. We get sampling frequency. Now for the folding frequency, we have a formula, fs upon 2. Fs means sampling frequency. So fs upon 2, we get the 50. In this way you can get the sampling frequency and folding frequency. So let's head to the next point. What is the frequency rate for the signal x80? So here asks what is the frequency rate. So for that, we'll go to the right, x80. Here x80 is given like 5 cos 600 pi t plus 7 cos 800, isn't it? So here you have to be careful one thing. So first you have to divide this part into divide by 2 into two part. You have to keep in mind that you should during dividing you should only divide by 2. Like 600 divided by 2 is equal to 300, and 800 divided by 2 is equal to 400. Like you can't divide 800 by 400, and like here you can write 200, so that will be incorrect. So you have only divide by 2 here, so that will be divided into two parts like this. So here we get 5 cos 2 pi. Here is 300, because 300 into 2, which is obviously 600. In this way we can partition this. So now it's time to comparing. So f1 is equal to this number will be f1 hour, and a1 is this 5. So in this way we will compare. So f2 here is 400, and a2 here is 7. So in this way we will compare. Now we get the value of f1, f2, a1, a2. So f1 means here frequency, a means attenuation. So after that here we have to find out fmax. So fmax is nothing but f2 is called as fmax. Here fmax is equal to f2, which is called 400, because f2 is here 400. If f2 is here 800, then we get fmax 800. So now here we have been asked, I think, Nyquist rate. Oh, here we didn't have to find Nyquist rate, but in some question we have to find Nyquist rate. So for Nyquist rate we can simply use 2 fmax. 2 fmax means 2 into 400. So f max is here 400 and we have to multiply by 2. So here we will get 800, isn't it? So this is so simple. Now let's head into the next point. So here we have to find out the discrete frequency, which is called xn. So we have to find xn, isn't it? So currently we have x8. So now we have to find xn. So for this this is very easy, nothing to do. For this, you can simply replace t by, this is t, sorry. So you have to replace t by n upon fs. So we already find out fs. We have fs is, where is fs? Fs is 100. 100 hours, isn't it? Fs is 100 hours. So we have to replace fs, we have to replace t by n upon fs. So let's get into the question. So here we have xn is equal to 5 cos 2 pi. This is the above x80. Okay, this one you have to use, this one, the partition one. You if you use like above one without partition, that will be wrong. So you have to keep in mind, you have to use this one. So after using this one, as I told you before, you have to just replace t by n upon fs. So here is the t, isn't it? You have to replace this t by n upon fs. So here we replace n is as it is, and upon fs means we get the fs is equal to 100. So I'll show once again, fs is equal to 100, isn't it? So n is as it is plus 7 cos 2 pi 400 upon fs is 100. So after that, this is going to be a cancel, 2 0 will be cancel. So 3 into 2 is equal to 6 pi, and here is 7 cos, this 2 will be cancel, and this 2 will be cancel here, isn't it? So 4 into 2 is 8 pi n. So in this way, we can get the xn frequency, xn discrete time signal. So you can also write this f1 dash is by comparing this.